Today we are gonna do a calorimetry experiment. We are gonna measure the enthalpy or heat of the reaction, and today we have the reaction between sodium hydroxide and hydrochloric acid, so it's an enthalpy of neutralization. So first we're gonna show you the equipment that we're gonna use. We're gonna use a calorimeter. It's a styrofoam calorimeter. We are gonna use this stirrer, magnetic stirrer. We're gonna put this inside. This calorimeter has a top, and in the top we have a temperature probe. This temperature probe is connected to the iPad via Bluetooth, and this probe is gonna measure the temperature, and we're gonna see here in the y-axis the temperature versus time. The first thing we're gonna do for the experiment is
add the sodium hydroxide solution that you measure out to the calorimeter and get a mass of our sodium hydroxide solution. And then we want to get it stirring.
Why do we need to stir?
So we want it to stir so that all of the sodium hydroxide reacts with all of the hydrochloric acid at the same time, and there's no temperature differences between different parts of the solution.
Okay, sounds great.
So once the sodium hydroxide solution is stirring, we can actually hit start on the iPad and start recording an initial temperature of that solution. And we can let this run for however long we want. It's not going to affect any part of our experiment if we let it run for too long. We definitely want to wait until it stabilizes, but you can let it go for however long you want.
It seems like it's stable at 21.5 Celsius.
Yep.
So now 21.1 actually. So now we can add the hydrochloric acid, right?
Yep, so you're going to measure out the appropriate volume of hydrochloric acid according to what's listed in the chart on your handout. And you're going to add it to an empty 50 milliliter beaker and get a mass of the beaker plus the hydrochloric acid liquid.
Why do we need the inverted petri dish here?
So the lab bench tops are very cold, and we don't want that to affect the temperature of the solution, because again, the main thing that we're measuring in this experiment is temperature.
Okay, so now we are ready to add the hydrochloric acid.
Yep, so while the iPad is running and the sodium hydroxide solution is stirring, all you do is lift the top of the calorimeter off and pour the hydrochloric acid solution in, and then put the cap back on, and you'll notice a temperature spike because this is an exothermic reaction.
It seems like it's reaching a temperature of 25.2 Celsius, kind of.
Yep, past 25, and you want to let it run all the way until we start to see a temperature decrease, because then it's not producing any more heat, essentially.
So we also have to re-weight the beaker with the residual hydrochloric acid, because if you look at the beaker, there is a little bit of solution there. So we need to make sure to do the calculations that we know the exact mass that we actually added into the calorimeter.
Yep. So now that the temperature is decreasing, we're going to stop the run on our iPad. And we're going to look for two things: the initial temperature and the final temperature. The initial temperature is the temperature of the sodium hydroxide solution before we added the hydrochloric acid. And the final temperature is the highest temperature that was recorded on the iPad.
So this way, we are going to calculate the delta T, which is the change in temperature, and using the equation Q equal mc delta T, we can calculate the heat of
this reaction.
Neutralization, yeah.
Yep.
And one more thing, we are going to assume that the calorimeter, the styrofoam, is actually not absorbing any heat
Right.
in the reaction, and all the heat was taken by the solution.